Thank you. My name is Fred Lubnow. I'm with My name is Fred Lubnow. I'm with Princeton Hydro, and we're the organization. I've been with the same group of people. We've been monitoring Lake Hopatcong since I've been a consultant in the early 90s, but even before then, we've been monitoring in the early 80s. So we have a pretty long data set on Lake Hopatcong and its water quality. The presentation I'm going to give is about 10 minutes long. It's basically taking a half-a-day course that I developed on cyanotoxins and crammed it into 10 minutes. Plus, I added some specific stuff for Lake Hopatcong, specifically for your lake.
Hold it right on your mouth.
All right. Right here? Okay. All right. So the objectives of the talk. Number one, what are blue-green algae, also called cyanobacteria? 2, what are cyanotoxins? And 3, how are we going to deal with this in terms of long-term management? Cyanobacteria, they're bacteria. They're very old organisms. They've been around for a very long time, so they have some pretty unique adaptations. Number one, they can photosynthesize in all kinds of light intensities. So they can photosynthesize down deep or right at the surface. Number 2, they have these resting spores called aconites. So they're, like was previously mentioned, they're in every lake. When times get cold, they form these aconites. These resting spores go to the bottom, and then when the lake turns over in the spring, they come back up and hatch. So they are very resistant to a wide variety of environmental conditions. Many of them can fix their own nitrogen, which is really important. What that means is they can take nitrogen from the atmosphere and use it for fuel. But to do that, it takes a lot of energy. That means they need a lot of phosphorus. And that's one of the reasons why with freshwater lakes, we really focus on reducing phosphorus concentrations going in. That's what the Commission and the Foundation have really been pushing for years, if not decades. We need to starve the algae, essentially. And they love phosphorus. They have enzymes to cleave phosphorus off of particles or off of organic material. So they're very good at scrounging around for phosphorus. They can regulate their position in the water column. That's why you see those nasty surface scums. If they want all the light, they go right to the surface, they photosynthesize all they want, then they can drop down to deeper waters and fuel up on some of the nutrient-rich deeper waters. So they have all kinds of unique adaptations. And then finally, they're not grazed on like other algae. So there are a lot of algae, green algae, diatoms, chrysophytes. They're the good algae. They're the base of the aquatic food web. The blue-greens, they're not very tasty. Number one, they generate the cyanotoxins, and number 2, they make these large colonies, which is what you're seeing. So they have all these unique adaptations. It's very critical that you identify what the algae is, and this was mentioned by DEP. So on your left, you see a bloom of a cyanobacteria. On your right, you see a bloom of euglena. And just looking at them with the naked eye, they look the same, but it's this one here, this anabina, this blue-green is the one that can generate the cyanotoxins. So you need to do some microbiological investigation and identify what that algae is. A bloom of euglena, which is something you've seen in like high school or college biology, they do not generate cyanotoxins. We did find the 2 main culprits of the bloom, Dolictospermum and the other one, Moronichia. We found both of those in our samples as well. Those were the ones that DEP identified as being the culprits. Now, there's a lot of dispute about the one over on the right, whether or not it generates cyanotoxins, but the Dolictospermum absolutely does. When we did our sampling, so we sampled on the 2nd of July. So as part of our contract with the Lake Hopatcong Commission, we do water quality monitoring 5 times over the course of the growing season from May through September, and then we do 2 cyanotoxin events where we're going out and we sample at 8 near beach locations. We were originally going to do it in late July, but obviously with the bloom, the Commission asked us to go out early. We went out on the 2nd. So we're actually out on the same day. So we did some sampling as well at those 8 locations. One of them was the mid-lake. And same with DEP, we saw cell counts higher than 20,000 cells per mil, but Almost all of our others were below the 20,000. So of the 8 sampling sites, 2 had 20,000 cells or greater, the others did not. I can say that with our cyanotoxin testing, all of our results came out negative. Now, we use a field meter. It's very different than DEP taking their samples to the lab and then they actually generated numbers. Our field meters are basically identifying whether the toxins are there or not. And for the 2 that were identified, the microcystins and the cylindrospermopsum, we were getting negative readings at all 8 stations. But like I said, 2 of our 8, we did have elevated concentrations of cells, and that's what that advisory is related to, is that high cell count is indicative of something that may have some sort of issue related to like a skin rash or some other respiratory disease associated with a different cyanotoxin than the ones that are being measured. I want to emphasize, if you want a bloom, you need 3 things for the cyanobacteria. You need high water temperatures, you need still water conditions, and you need elevated phosphorus concentrations, typically greater than 0.03 milligrams per liter. If you have those conditions, that's usually when you're going to get a bloom. And when we looked at the precipitation data over the course of June, this is showing you how much rain fell over the last month. And I can tell you that we did our water quality monitoring on the 14th. So we went out there right after that storm event, and we got elevated phosphorus concentrations. So what that tells us is these rain events were washing nutrients from the watershed into the lake. And look at how this pattern was set up. We were getting these storms, and if you remember, from the week of the 17th on, we would get like 10, 30-minute storm events, and then the temperature would go up to 70 and 80 degrees. Storm event, 70, 80 degrees. On top of that, the following week, we had that mini heat wave. So these conditions really helped to create this situation where the bloom occurred in Lake Hopatcong. And that's what generated these blooms. It's the watershed being washed, carrying these nutrients into the warm water, stimulating these blooms. Now I can tell you that you've had these blooms periodically from time to time. We've actually been seeing them late in the fall, but the difference is in the fall there aren't as many people out on the lake or directly recreating. But this is from a bloom. This looks like midsummer, but this was mid-October. And I can tell you that in 2016 and 2017, some of the lakes that we monitor, we had some of these blooms that were persistent well into November. I'm sort of dating myself, but when I started as a consultant in the early 90s, once we hit September, cooler temperatures would show up, and then these blooms would crash. So over the last 10, 20 years, we're seeing more and more of these blooms persist further and further into the fall season. And I want to also emphasize, you are not the only lake affected by this weather pattern. We monitor a number of lakes in Pennsylvania, in New Jersey, and New York, and this same pattern happened. This is Harvey's Lake in Luzerne County, Pennsylvania, which almost never gets cyanotoxin blooms. In the exact same week, Lake Hopatcong, you had your bloom, Harvey's Lake had the exact same bloom. For the last 3.5 weeks, this is all I've been dealing with, which is why my shirt's green, because this was actually originally white. But I mean, this is something that has been all over. So there were situations at Lake Mohawk, Spruce Run, Swartzwood. We've been seeing it in Pennsylvania, in the Poconos, Harvey's Lake, Waynwood Lake, Octoraro Reservoir. We've been seeing it in New York. DeForest Lake had a bloom going on. So this is something that was affecting larger lakes throughout the region. I'm not going to get into climate change, but I can tell you that we're seeing increasing concentrations of carbon dioxide, and this is something that's not just modeled. These are measured concentrations from one of the climate stations in Hawaii, where we see CO2 concentrations on the rise, and what we see is the temperature in the mid-Atlantic states, in the northeast region of US, has increased. What does that do to Lake Hopatcong and this region of the United States? Well, the one thing that all these models and all this data is telling us is that we're going to be warmer and wetter as we go further and further into the 21st century. This is just a fact. This is why when I started as a consultant, again, I sound like an old guy, but when I started as a consultant and we were doing winter sampling, we used to, if we went up to Culver Lake or Swartzwood Lake, we'd have to move the snow, carve through a foot or two of ice, and grab our samples. Now we're lucky if we can even get on the ice. So we're seeing these milder and milder winters. The temperature increase between 3 and 7 degrees Fahrenheit. More importantly, more extreme heat days over the summer season. This means this gives fuel to the fire for these cyanotoxin producing bacteria. An increase in the frequency of extreme weather events. That means more flooding, more droughts. But probably the most important relative to the cyanotoxins, growing season could increase between 15 and 30 days, and we're already seeing that. The last 3 years, I've seen the growing season go from toward the end of September to the beginning of November. And then finally, the number of frost days could decrease by 20 to 40 days. So we are seeing how climate change is affecting these organisms. So how can we help to reduce the severity of these blooms going on into the future? Well, one is controlling their food, which is the phosphorus. So, New Jersey DEP does have a nutrient criteria for total phosphorus for any water body. They want to make sure that the concentration is at or below 0.05 milligrams per liter. But they do allow for circumstances, if you feel your water body is sensitive and you need a lower concentration, they will designate that. And that's exactly what we did for Lake Hopatcong back in 2016. We developed a watershed implementation plan which was based on some modeling that DEP did on the lake and watershed. So we identified that Lake Hopatcong is sensitive enough that we want the phosphorus concentrations in Lake Hopatcong to be at 0.03 milligrams per liter or lower. And we're currently updating this plan. So the plan was completed in 2016. The commission received some funding through the New Jersey Highlands Council to update that plan. This is a really important slide, and the reason why I did this once everything hit the fan, and I wanted to look at the June concentrations of total phosphorus. So this is, and I just happened on my computer, I had the last 17 years of data for Lake Hopatcong. We have data going into the early 80s, but a lot of that is in boxes. I have some of our interns pulling all that data out, but at least if we look at 17 years of data, and this is the average June concentration, and I can only say June because we're in early July. So, and each data point represents about 8 points throughout the lake. What I want to identify is this year was the highest June concentration we've had in the last 17 years. So we want to stay below 0.03, but if you look at this past June, we were at, the average was 0.043. Above that criteria. So that, again, warm water conditions, higher phosphorus concentrations, that's what triggered the bloom. And like I said, we went out there, the day, that last storm on the 14th happened in the morning, we were out there and we measured, and that's the elevated phosphorus concentrations that stimulated this bloom. So I'm not going to get into too much detail since this was already touched upon. What are the cyanotoxins? There are these low molecular weight compounds that can negatively impact people, pets, and livestock. There are 3 main types: hepatotoxins, neurotoxins, and then dermal toxins. I want to emphasize something because this is constantly coming up. Cyanotoxins are odorless, tasteless, and colorless. You can't see them, you can't smell them. This is really important, and this is something that a lot of drinking water companies had to come into the realization. If you're smelling something bad, it's probably a compound such as geosmin or MID. If it smells musty or like rotten fruit, those compounds are different than the cyanotoxins. So just because you're smelling something nasty doesn't necessarily mean you have cyanotoxins. But just because you're not smelling anything doesn't mean that those cyanotoxins are not present. So keep that in mind. You can have water bodies that create these nasty taste and odor compounds and not produce any cyanotoxins, or you could have the reverse, where there's no taste and odor problem, but they're generating cyanotoxins. Again, we touched on this earlier, some of the more common cyanotoxins, the microcystins, Cylindrospermopsin, Anatoxin A. Like I said, when we went out the 2nd of July, with our field meter, which is different methodology than the lab, we were getting negative results. What triggered all this concern, and it was touched on earlier, was Lake Erie, Toledo, Ohio. And if you look on your left, you can see that the western part of the lake was just inundated with a massive bloom. That's really what triggered this concern over cyanotoxins. It's one of the reasons why we started getting into investing in purchasing these meters and doing this monitoring for both drinking water and for recreational water bodies. I'm not going to go into too much detail over this, but basically, EPA has their specific criteria for the cyanotoxins, but EPA is also considering whether or not to make these compounds regulated compounds. So they're currently under a 3-year study to determine if these should be regulated. So for the round of unregulated compounds, there's 30 of them they're considering, 10 of them are cyanotoxins. That study will be completed in 2020. New Jersey's concerned, so it was already mentioned, they do the visual observations. They have concerns over the cell count. If you have greater than 20,000 cells per mil, that can trigger an advisory or an issue of concern. And then also, this is what their thresholds are relative to EPA's. So New Jersey DEP has thresholds of concern for microcystins, for Cylindrus spermopsum, and for antitoxin A. EPA right now has just for the first two. EPA is currently doing a very extensive study and review of the data to determine if there should be one for antitoxin A, and if there is, what that level should be.
Are we above the EPA threshold?
I'm sorry?
Are we above the EPA threshold?
No. If you look, the EPA thresholds are actually higher than the New Jersey ones. The New Jersey ones are even lower. So let me get through this. I'm almost there. So the concerns over the cyanotoxins in Lake Hopatcong. So in response to a bloom back in 2014, actually DEP did some sampling back in 2014. And they did find some elevated cyanotoxins along some shoreline areas that did not have beaches. They did testing at beaches and found it below the beach areas. Because of that, we were working with the commission and with a grant, a 319 grant focusing on stormwater. We had some extra money, so we said, hey, 2015, could we do some cyanotoxin testing? And we did. Back in 2015, negative results. So back then, we were just monitoring for microcystins. Now, back in 2017, the commission approached us and said, hey, we're concerned about cyanotoxins. Should we be monitoring for this? So we recommended that we start a long-term cyanotoxin monitoring program. So we're out there twice over the course of the growing season to collect samples at 8 beach locations, which is what I've already described. So last year when we did this, we did it twice, once in July, once in August, all negative. There were obviously no issues last year associated with cyanotoxins. Like I said, we were out there July 2nd. We did not get any hits for the samples that we collect. So what can be done about these cyanotoxins? What can we do to avoid, prevent, or minimize these blooms? Well, there's a 3-tier approach. The one I'm not going to address are the global issues associated with climate change. I'm not going to focus on that, but what I will focus on is we're currently updating your watershed implementation plan. That watershed implementation plan is a guide, a blueprint that shows what can be done within the watershed to reduce your phosphorus loads going in. So the first plan was done in 2016, and when we did that plan, the commission, the foundation received a number of grants, and we've implemented a variety of stormwater projects and septic projects and programs, and we reduced the targeted amount of phosphorus that needs to be reduced in your lake by about 1/3. So we got about 33% of it done. We still have anywhere between 65 and 66% to go. So we've been making progress, but there's still more to go to reduce these phosphorus concentrations. So again, that's the long-term goal is, for a watershed basis, we want to all pitch together and really focus on stormwater management, septic management, what you can do on your individual lots to minimize your load of phosphorus going into the lake. That is really important. And then the 3rd tier approach is something that actually New York's been doing more and more of, is in some of the larger lakes where you have beaches or bays or coves, if you have a community around a beach, that beach should have its own little restoration plan. Because very frequently these blooms will either start in a beach or cove area, or they're coming in by the wind, blowing the cells along your shoreline or into your bay, concentrating those cells. So what can you do to develop a restoration plan specifically for your bay and cove? And there's, this is just showing you the Lake Hopatcong watershed, how extensive it is. But in terms of potential restoration measures for your bay, your cove, your beach, there's a number of things you may want to consider. But again, you need to do some homework and understand what the average depth of your bay or cove is, understand what some of your, how the wind patterns are. And if you're interested in that, please contact the commission, because we have a lot of data that we may have for your bay and cove that you can use to develop such a plan. So these plans would consider the possible use of aeration or circulation systems or bubblers to try to avoid the accumulation of cells along your shoreline. The very careful use of algicides. I mean, we don't really like to use copper-based algicides because when you hit the cells with the copper, they lyse, and those toxins that are in the cells are more than readily available. But if you're going to use copper, do it in a more proactive than reactive. We've done that where you can focus on knowing when that bloom's going to come and using less copper, get it under control before it gets completely out of hand. But then there are alternative products like strong oxidizers that can be used as well. They're more expensive, but they don't, number one, they're not adding copper into the system, and number two, there's some studies to indicate that some of those strong oxidizers may help to break down the Cyano toxins as well. Floating wetland islands, ultrasonic devices. The ultrasonic devices, I've seen them work, and I've seen them not work at all. So again, it depends on your site-specific conditions. Possible mechanical or physical removal, and I've only seen that happen one place out in California, which had way too much algae that you wouldn't even consider recreating in that lake. And then possible nutrient removal through phosphorus stripping in the water column with a nutrient inactivator. So those are some of the in-lake measures that you could consider. But again, keep in mind, what's your immediate drainage basin like? Do you have an existing septic system? And if so, is it pumped out on a regular basis? And if it's not pumped out and if it's associated with a club, could you possibly get some sort of funding or some sort of alternative source of revenue so you can replace that existing septic system with, say, like an incinerated toilet or a dry toilet? Something that you certainly wouldn't use in your home, but for a clubhouse, is something that many people will utilize in more of that recreational setting. Shoreline stabilization. Whenever you have exposed dirt, any dirt that falls into the lake has phosphorus stuck to those soil particles. And that phosphorus goes in and it stimulates that growth of the algae. So if you can stabilize your shoreline, with vegetation, that goes a long way. And then goose management. Geese are the only bird that generates more phosphorus than a goose is a cormorant. You know how filthy cormorants are. Geese defecate on average 27, 28 times a day. So I would hate to have been the grad student that figured that one out. But they generate a lot of phosphorus. It's because they're constantly eating vegetation. So they're cows with feathers. They're constantly pooping. So they generate a lot of phosphorus. So some aggressive goose management can go a long way. Source control management. Pick up after your dogs. I have on her good days, she's 48 pounds, but on her bad days, she's 50 pounds. My English bulldog, Zoe. She generates about 2 pounds of phosphorus a year. So I know when I walk her, I have to pick up the poop. Keep in mind that 1 pound of phosphorus dumped into a lake or pond has the potential to generate up to 1,100 pounds of that green goo you see in a lake. So it doesn't take a lot of reduction of phosphorus to have a measurable response. So remember that 1 pound can generate up to 1,100 pounds of algae. So minimizing that phosphorus is really key. And then finally, green infrastructure, stormwater BMPs. Anything we can do to minimize the phosphorus before it goes into the lake will really help to maintain the water quality. Like I said, we started back in 2016. We are moving forward. We're about a third of the way there in compliance with the overall plan. We're now going to move forward for another, hopefully 2 months we'll have the revised plan, and then we're actually going to go to DEP and ask for some potential, with some of their potential sources of grant funding. Maybe we can get some additional projects in the ground to do some additional stormwater work. So I know that was a lot of information, and I thank you for your attention. Thank you very much.